Alright guys, we're going to do this really quickly. This is just a review from your homework problem. We're trying to find the derivative when for f prime of x, when f of x equals x minus the square root of x. So let's first write the limit definition of a derivative. It's the limit as h approaches 0 of f of x plus h minus f of x all over h. So remember from class today we talked about first in our steps we're going to plug in x plus h. So our function x minus the square root of x. Wherever we see an x, we're going to plug in x plus h. So we have x plus h minus the square root of x plus h. So that's our first step. Now we're going to find what? We're going to write in our function f of x. So we're going to subtract x minus the square root of x. This is all over h. Keep writing our limit as h approaches 0. Alright, now we can simplify a little bit. Our x's cancel out. I'm going to distribute that negative sign. So I'm left with h minus square root of x plus h plus x, square root of x, all over h. The limit as h approaches 0. Now, here's the hard part. For right now, I want you to just ignore the h's. I want to get rid of this square root sign for both of them. What we talked about in class is we're going to multiply by the conjugate pair. So the negative square root of x plus h minus square root of x. There's our conjugate. And whatever we do to the top, we're going to do to the bottom. So we get negative square root of x plus h minus the square root of x. This is our conjugate pair. And really we're just multiplying this quantity right here by 1. So we're not changing anything. So what happens? Well, by design, we're going to have these two multiplied together. We get x plus h. Middle terms cancel out, so these multiplied together minus all over negative square root of x plus h minus square root x. Okay, now what do we have? Well, let's write this out as a fraction. We have the limit as h approaches 0, h over h minus, well, our x's cancel out here. So I have h over h times negative square root of x plus h minus the square root of x. Well, this term here is just 1, so that's 1. The limit as h approaches 0 minus 1 over square root of negative x plus h, sorry about that, minus the square root of x, because our h's cancel out up here. So last step, we can evaluate this at h approaches 0. So the limit as h approaches 0 of 1 is just 1 minus, well, 1 over negative 2 square root of x. That's our limit evaluated, which means that's our f prime of x. Thanks.